Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where I will show you how to use our fully integrated environment Omnis in short videos of a few minutes. In this video, I'll show you how to use the family tree and geometry views to link entities for turbomachinery meshing. Select the Autogrid template on the Welcome page if the objective is to simply mesh a turbomachinery configuration. If the target also includes launching the flow solver, the turbo template can be directly chosen. Let us start here with the turbo template. The geometry context is composed of 3 panels and 3 views. The left side is composed of 2 panels, the family tree and its property tab. The right side is composed of 1 panel, the CAD tree. The top view is a 3D view showing the entities of the CAD tree. The bottom views are the meridional on the left and 3D turbo on the right, showing the entities of the family tree. The geometry used for an Autogrid mesh can be defined by importing an existing file, GeoTurbo or Autogrid template, or by importing and linking CAD entities to turbomachinery entities. Click on the import icon in the CAD tree toolbar or in the pie menu and select the geometry file. Omnis is compatible with several formats including Parasolid, CATIA, IGS, STEP, SolidWorks, STL, and many others. The geometry is loaded in the 3D view and in the CAD tree. The CAD tree shows all CAD entities. In this example, we have the channel curves, hub and shroud, and one blade row described by a single passage rotor blade with suction and pressure sides. The family tree allows to link imported CAD geometries to predefined turbomachine entities such as hub, shroud, blade, leading and trailing edge, or the assembly boundaries. 3 types of configurations or assembly can be created using the buttons in the toolbar: turbo configuration with bypass, and new non-turbo assembly. The turbo configuration is composed of a channel defined by its hub and shroud and a row including a main blade. This also includes predefined assembly boundary condition type in the geometry context, such as inlet and outlet. When created, additional rows and blades in the row can be included by clicking on the plus symbol in the family tree in front of respectively the turbo configuration or the row assembly. Similarly, the turbo configuration with bypass creates a turbomachine configuration with a bypass composed by its hub, nozzle, and shroud, and a row in front of the nozzle including a main blade. This also includes predefined assembly boundary conditions type in the geometry context, such as inlet, outlet, and outlet 2. The general non-turbo assembly is used for non-turbo configurations like volutes and draft tubes. A set of assembly boundaries must be added below the assembly, and their type should be specified in the boundary tab in the property panel. In this example, we start by clicking on the Create Turbo Configuration icon to create a predefined turbomachinery configuration to which the imported CAD geometry can be linked. Using the Surfaces and Curves graphical selection mode, the curves and surfaces shown in the 3D view or listed in the CAD tree can be interactively selected by the user. Once selected, the geometry entities should be linked to their corresponding turbo configuration entity, which are identified by their unique red icons in the family tree. Note that only surfaces related to the suction and pressure sides, together with the surfaces related to a round or sharp leading and trailing edge, should be linked to the blade. By clicking the red icon dedicated to the concerned entity, the selected surfaces and curves will be linked and the icon will turn green. The linked entities will be shown in the meridional and 3D turbo views. Already linked curves and surfaces can be updated anytime by selecting the new curves or surfaces and clicking the concerned green icon again. For example, we can update the shroud entity with both shroud curves by selecting the curves, pressing the Ctrl key, and relinking them in the family tree. Notice that the bottom views will get updated, confirming the operation. Omnis Autogrid requires that the blade surfaces and leading and trailing edge intersect the channel curves, hub and shroud. Make sure to enforce that by dismissing any error message and by expanding the blades under the blade control panel of the main blade entity of the turbo configuration. Here, an expansion treatment can be applied at the hub and shroud locations once the expand option is selected and the apply blade treatment button is pressed. The method is fully automatic without user inputs, and the blade entities are updated in the meridional view. Click on Check Blade Geometry to perform a geometry check. Omnis will assess if a single body can be created using the sewing tolerance to fill potential holes between the surfaces defining the blade. A success message should pop up on the top right of the GUI. Click on Row 1 and finish defining the row parameters which will be carried to the mesh context, such as row type, extra turbine, Francis turbine, inducer, extra compressor, extra fan, row periodicity, which defines the number of blades in the row and updates the 3D turbo view, the row rotation status, rotor or stator, an option to enable the tandem row feature, and gap fillet options. In this case, we have an extra turbine with 41 rotor blades with a tip gap of 0.4 mm at the leading and trailing edge. More advanced turbomachinery features such as non-axis symmetric hub and shroud, fillets, tandem row, ZR effects, and bypass are covered in dedicated videos. Lastly, when all geometrical CAD entities are properly set and associated to the turbo configuration, click the Create Mesh Setup icon in the Family Tree toolbar. In the mesh context, an Omnis Autogrid mesh setup is automatically created and is ready to be meshed using the Row Wizard or manual settings. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.